Hi everyone. Today we're going to be looking at the EasyPLC Paint Line bit shift, BRX Do-More PLC. Now the machine simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that are used to show different programming techniques. The Paint Line is one of these machines. It will use bit shift or shift register to track bottles along a conveyor belt. All of the bottles will be detected using photocells and tracked along the conveyor. Larger or taller bottles will be painted and then pushed into a box at a station of the conveyor belt. A control panel will be used to start and stop the paint line and display the bottle count. The Paint Line machine simulator is an excellent way to learn how to program shift registers in the PLC. Now the BRX Do-More PLC will be used to control this virtual paint line machine. Using the BRX Do-More PLC, we will connect to the paint line machine. This will be done using Modbus TCP or Ethernet for communications. And using the 5 steps for program development, we will show you how this is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So the first step in our EasyPLC Paint Line is to determine the task. So if we call up our machines, or we can hit start, you will see that if we scroll down, we will actually see our paint line, which is located right here. If we click on it once, you will see that we have what has to be done here. And it basically says there's 2 types of canisters pass through the painting line. Some are white tall and others are blue and smaller. The object is to paint the canisters while at the painting station and eject them onto the pallet located on the side of the conveyor using the eject cylinder. Blue cans must not be painted and must fall off the pallet at the end of the conveyor. And then it goes on to say there are 2 photocells located at the beginning of the entry line. Photocell 1 detects each of the cans at the entrance, and the photocell 2 only detects the tall cans, or the white ones. That's the ones we need to be painted and also ejected. And now, taking into account that the cans come along the line at the same distance, use a stack light data structure to manage the painting and launching of the cans when they arrive at each of the stations. And a bit shift operation is recommended to manage the logic. So that's the description of what has to be done. If we go to the paint line, we can actually call up the demo, and the demo will actually give us a good idea of actually how this is to operate itself. So it just takes a second or two to load this up, and once it's loaded, we will actually see the actual running of this paint line. Here we go. You can see there's our demo mode, and this is our 2 photoelectric sensors detecting the size of the bottle that's coming down here. And you see these are all equal spaced along here. So once we get into the paint line here, there's my paint can. It should spray this bottle here. There we go. So it paints it yellow and then sends it on. We have 2 curing lights for the paint. And then when we get to the end here, we have our ejector, and the ejector will eject the yellow painted ones into this pallet right here, and on the end of the pallet the blue ones will fall. And our first eject is right there. So we can actually speed this up. We can do 2 times or 3 times, so we can actually see the operation of this process. And what I can do is we can now just move around just to make sure that we actually understand what's going on. And here we go. We'll just go like this. And you can see here we have our start, we have our stop, we have our display of our painted parts, we have an emergency stop. And you see as it comes into our paint booth, it actually paints only the ones that are taller. If we go back, we can see here's our two photocells. The bottom one here will light when we have a bottle, and the top one will light when we have a tall bottle. So that's how we keep track of the items coming onto the conveyor belt. So the small one will only light the bottom one, and then the tall one operate the two. If we go down and look at the end of the conveyor, we can pass right through. There's the two light. And here is our reject. So we're just rejecting the bottle, and the blue ones are passing right through and onto the end. So if we look at our, the next stage is to actually, once we have a good understanding of what's going to go on, we have to look at the inputs and outputs that are required to do this operation. So we can hit View I/O here in demo mode. And you can see here my outputs. I have my conveyor on. I have my paint to paint the actual bottles that we need. We have our pusher advanced. We have our start button light, and we have our stop button light. So basically we only have 5 digital outputs from the PLC that we're going to be controlling. On the input side, we have photocell 1 to detect when the bottle's coming, photocell 2 which detects our large bottles. We have our start button, we have our stop button, our emergency stop, and we have our pusher advanced. So when the pusher is advanced all the way, it detects it, and then we can retract it. So that is our physical I/O. And our analog out, we can see we have a display to display the number of actual tall bottles that we've painted. On our analog out, or inputs, we don't have anything at all. So we just have the one analog out. So after we determine what actually has to happen, what we have to do is develop a logical sequence of operation. Now, usually a flow chart or sequence table is used to understand the process that needs to be controlled. And it must answer questions like what happens when electrical power or pneumatic power or air is lost, what happens when the input and output devices fail, and do we need redundancy? These are the things, there are types of questions that need to be asked. Now, this step is where you're going to spend most of your time. Trying to understand everything about the operation will save you time. It will help prevent you from continuously rewriting your PLC program logic. Knowing all these answers up front is vital to the development of your PLC program. Now, if we look around or zoom around, what we can see is, and what we'll do is just zoom right up to the ceiling, and we can turn around and we can look at this conveyor from a ceiling point of view. And so you can see our different bottles coming in. We can see this is like positioning of our shift register. So if I take a look at what I mean by that, is here's an example. So here's our bottle coming in, and the bottles are equally spaced. So that means that each position that we have here represents, say, a bit within a register. And here's our bit shift position. So there's position number 1 to position number 17. So that covers the entire length of my conveyor belt. And then I have shifted data in here. So if it's a small bottle, I shift a 0 in. If it's a large bottle, I shift the 1 in. And each time I get that photocell 1, it shifts that over. So it gives me the equal spacing along. I know that at position 6, I have my paint gun. So if I have a 1 in that, then it will fire the paint sequence. When I get to the reject, this is at position number 16. And if I have a 1 there, it ejects it. So that's the basic operation that I'm looking for within this program. So the other thing that we can do is we'll have the green start button that will start the line, and we'll have the red stop button that will stop the line. And if the emergency stop button is activated, the paint line will not run. So let's just go back to our demo here, and let's just go down and take a look at the paint. There we go. So now if the line can be started, then the green light will be on. If the line is running, then the red light will be on. This is how we're going to program it. And if the emergency stop button is activated, then both lights will indicate or be off, so that indicates that we have emergency stop conditions, so that it indicates to the operator that there's something wrong here and that you have to clear that emergency stop. Now, the painted parts will be displayed on the panel. So if the line is running, then and the start is pushed, then we want the total blue parts to be displayed on the panel. And if the line is stopped and the stop button is pushed, then the total blue parts in the display will, or the palette will be displayed. So we were going to add to this simple painted parts display. So when we hit when it's running, we hit the green light and you will see the number of blue parts in the palette at the end of the conveyor belt. If not, then the display is going to be the painted parts. And if it's stopped, we hit the red light, it's going to display the number of parts in the blue. And then what we'll also do is be able to reset these counts by stopping the line, holding the stop button for more than 10 seconds. When that happens, then we reset those containers, or contain those parts totals. So that is our operation. Let's just exit this. We'll go back to the main. And once we're back at the main, what we'll do now is go onto our next step. Since we have a good indication of our tasks that we have to have, our I/O, and our sequence of operation, now we can develop the BRX Do-More PLC program, which is the fourth step of our EasyPLC Paint Line. And what we'll do is use the Do-More Designer PLC software package. And what we'll do is take a look now, and we will see that on our EasyPLC Paint Line bit shift, what we'll do is, the first thing we'll do is the conditions that will start the conveyor. So if I look at the first rung, we have a start push button. So when the start push button is energized and we do not have the start or the stop, and the emergency stop is not activated, so that means that it's on all the time, then we turn on our conveyor belt. If the emergency stop button is pressed, or the e-stop, or the first scan, then we reset our conveyor belt. So stop the line. Now the start line, if it is, if we don't have the conveyor belt on, and we don't have the stop, or the emergency stop has not been hit, then we will have the light for our start being on. And if the conveyor belt is on, then our stop is off. So if emergency stop switch is hit, what will happen is this will drop out both of these, so no lights will be shown. That's exactly what we want. Then what we have is our shift register. So the shift register actually contains 3 different lines of code. The first one is the data. So the data coming in, we want to put a 1 when we have a tall bottle. That means that photocell number 1 and number 2 will be on. With the conveyor belt, that will give us our signal to go into the shift register. The next one is our clock flag, or when we shift those bits. So when the conveyor belt is on and we have photocell number 1 on, which is the bottom photocell, then what we want to do is then shift those bits in. So it takes whatever's on this input side, and it will put a 1, if it's a tall one, into the shift register, and then we also shift that over into the position. Then we have our first scan, which will reset it, or our reset of our counters will also reset our shift register. Then what we do is, then from the shift register, because that's controlling everything, what we do is control the paint at position number 6. So our shift register, if we go back here, will actually be from C0 to C31. So we have 32 bits in our shift register as we go through. And the paint position is going to be 6, as we saw before on our diagram, which is actually C5. So that means when the conveyor belt's on, we have photocell 1, which is our sequencing or our timing, and we have position number 6, then we turn our paint on. Then we have our pusher. Then if we have the machine on, we have photocell number 1 on the leading edge, and we have C15, which is position number 16, which is where our reject is. Then we advance our pusher, and we advance that through a set condition. Then when our pusher advanced input comes in, then we reset that pusher. Then what we do is we want to total the number of color painted bottles on the pallet. So during the pusher advanced, we use the start signal here, and then we can increment our total painted. Then we want to detect the number of smaller blue bottles on the conveyor line. So first of all, we have to account for all of the bottles that are existing on the conveyor belt. So that's why we have to compare this total to greater than 17, because there's 17 locations on the conveyor belt. Then C17, which is our last, or where our pallet's going to be on the end of the conveyor belt, and we have our one shot here of our photocell giving us our timing. Again, if we have all those, then we'll increment our blue count within the pallet at the end of the conveyor belt. Then our photocell will detect on D2 minus 17. And what this will do is, because it's detecting every time we do a signal minus our 17 inch on our conveyor belt, that will give us a grand total. And it'll be plus and minus 1 because of the reject station, because we're off the one side. But it's going to give us a really good idea of how much total that we're going to have on this conveyor belt itself. So we actually have 3 different counters altogether in this system. Then what we have is our reset for our counter. So when we have our push button and we hit it, we do a on delay time of 10 seconds. And when that timer expires here, then we move 0 into D0, 0 into D1, and minus 17 into D2, which resets the entire sequence. We also reset it by doing the first scan. Then we have our display of the white bottles and display of our blue bottles at the end of the conveyor. So when we have always on, we always display 0 into MHR1, which is the output of our simulator. So we display that on our screen. Then if we have our push buttons hit, then we move 1 into 0, which is our blue count. So that's exactly how we do it. Or if we have the stop button, we also display our blue count. Then with the BRX Do-More PLC, what we have to do is, right now we've been working with all the Modbus addresses. So if we want the physical outputs over this PLC, what we have to do is actually put the physical output on it. So we hit conveyor belt on, we do Y0. The paint on, we do Y1. The pusher, Y2, and then we have our start and stop, which are Y3 and 4. And then we have our end statements. So that's our entire program that we have in the PLC. Now next, what we have to do is we will determine, once we have our program developed, we save that, we download it, and I'll give you a link in the description below that will give you the entire series for our BRX Do-More PLC. We'll look at the system configuration. And under system configuration, we're going to use the Ethernet port, and we're going to use this right here, which is 192.168.1.11. And you can see we can configure that, and we can set our static IP address. So we also see that we have our Modbus TCP server also enabled, and that's enabled by default. So we got to make sure those are both activated, which they are. And we have to make note of that IP address when we go back to our machine simulator. So once we have that and it's running right now, we'll go back to our machine simulator. And again, we can hit start or we can hit machines. We'll go down to our paint line again. And our paint line will hit start to actually start that paint line up. And the first thing you will notice is that we have no PLC connected. What we can do is we can put in the I/O drivers. In our case here, you see that it defaults as the EasyPLC. What we want to do is select the Modbus driver, because we're going to go into the Modbus of our CPU unit itself. And we will configure that Modbus driver. You can see we're going to use our TCP IP port, which is our Ethernet. It's going to be 192.168.111, the same one that we just saw in the Do-More Designer software package. Then we're going to have our digital input start at 0, digital output start at 0, and analog input start at 0. And then what we'll do is, once we have those set, we'll hit OK. And it brings back our inputs and our outputs. Now, we can manually move this over, or we can hit driver and automatically assign the inputs and outputs for us. This is a much easier way of doing it. Then we can go to the exit and hit start driver and exit. Once we do, you can see that all our parameters are corrected, and we have our driver connected right now. And if we were to look at the actual physical PLC, we can actually see that we are communicating to our BRX Do-More PLC, and we're actually communicating through our Ethernet port located right here. We are in terminal mode. It's actually the program's running, and we have our first output, which we can see is actually our light. And you can see our light is actually lit here on our panel. We can view our I/O on our machine simulator. And when we do, you can see that our emergency stop is there. And what we can do is just, let's move down, and we will take a look at our control panel. Now you can see that we can start it. And this is our PLC now controlling the process. We can stop the conveyor at any time. We'll go to get a couple of bottles there first. Okay, we stopped it. You can see that I do an e-stop. And when I do, both lights go out, so I know that I have an e-stop, so I'll reset that one again. Start it again, and away we go. And just to make sure, we're going to paint that one. And sure enough, that's exactly what's going to happen. Yep, we painted it, and there's no issue there. There's our two reflectors here that are showing us what kind of bottle we have, either just a small one or a large one. And if we were to look at our PLC program, go back to it again, we also have our data table. And let me just move that down, and we'll move our data table in. There we go. And here you can see our different, on our shift registers, all the different bits that we have coming in. And you can see here our painted lines being painted. So if that represents an on bit in position 6, it'll be on. If not, it's an off. So you can see that going in there, that's an off. Until it gets to the reject station here, and you can see whether or not it has a bit. So that 14 goes on to here and shifts down. So very easy and very simple to actually visually see how your machine is actually operating. And what we can do is we can just travel again. We will travel down and take a look at our eject station. There we go. And you can see we can actually speed this up, our time lapse. You can go 2 times just to speed things up. There we go. And we can go back to our control panel here. And we can see now we have 14 on our count. If we want, we can stop that. And again, we have 18 total on the end of it. So that works well. Or if it started, you want to see how many? We have 20 at the end now. 17 in the painted ones. So very nice package to look at and program. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.